So in this video, we're going to be working with the medians and altitudes of a triangle, right? The median is the segment whose endpoints are a vertex of a triangle and the midpoint of the opposite side. So this is my vertex, and as the other endpoint is the midpoint of the other side, the opposite side. So the point of congruency is that point where all those lines, special lines intersect. So in the case of the medians, it's called the centroid, and it's that point where all the lines, all the medians intersect. So CP is a median, BM is a median, and AN is also a median, right? So it says that is 2/3 the distance from the vertex to the midpoint of the opposite side. So that means that CO is 2/3 whatever is the measure of CP, right? The same with AO. AO is 2/3 of the measure of AN, and BO is the same as 2/3 BM. And the altitude of a triangle is the perpendicular segment from a vertex of the triangle to the line containing the opposite side. So it's a segment that goes from this vertex and is perpendicular to the opposite side. So this one is asking us to determine if the line is a median, altitude of neither, right? So first of all, let's start by seeing that it begins on a vertex, and N is the midpoint of this side, right? How do we know? Because we know that the right side, this bit right here, is congruent to that one. So that means that MN is a median, right? On this one, I know that it starts at the vertex, but I don't know what's happening over here, right? And I know that it's not perpendicular because it's not telling me. So this one is neither. As a review, we know that it's an angle bisector because it's telling you that those two angles are congruent. So it divides that angle M into two congruent angles, right? Now, on the last one, MN, as you can see, it starts NN, and it's perpendicular to this side over here. So that means that this one is altitude. Okay, we want to find a median for triangle STU. STU, right? So we want to find a median. So in this case, on STU, it's the segment SB. So it's segment SB. As you can see, it starts with S, and B is the midpoint of TU. So that's the median, right? And altitude for that same triangle STU, right? So starting U, and it's perpendicular to the other side. So that means that UA, right? Triangle SBU is this one. SBU is that triangle right here. I'm looking for the median, so that means that it starts on a vertex and it intersects the other point in the midpoint. So in this case, segment BC, and an altitude for in CBU. CBU is this one right here. So my altitude is right there. I know it's this one because it's perpendicular to CB. So in this case, is UD. Yeah. So it says each figure shows a triangle with one or more of its median. Right? We want to find GE. Okay, so that means that LE is 11.8 because FL is a median. That means that this is congruent to that one. So that means that this one is also 8.8. So GE is 2 times 11.8. So that's 23.6. The next one. So KQ. So this one is 4. Again, that's a median. So this one is also 4. So in this case, LK equals 8. Now I have MV. So this one is 3.3, right? I want to find the segment right here. So as we know that the theorem states that VM equals 2/3 dm, right? So dv is going to be just 1/3 of dm, right? Why? Because I need to complete that whole number, right? So 2 plus 1 is 3, so 3 divided by 3 is 1. So there I have my whole number. So as you can see, this part, VM, is double whatever is this one. So that means that when I have the segment, so NV, half of NV is going to be equal to dV. So again, this piece right here, the longest part of that median, is going to be double whatever is this small part, right? So if we go the other way around, that means that this is half of that one. So in this case, dV equals 1/2 of 3.3. So that means that dV equals 1.65. Okay, so this one I want to find, I have WB, so I have that this one is 3, and I want to find this whole segment right here. So segment PB, right? So again, as we saw on the previous exercise, so segment 1/3 segment PB is going to be equal to WB. So the small piece is just 1/3 of the whole segment. So in this case, 1/3 of PB equals 3. And I'm just going to multiply times 3 on both sides so I can cancel out this one. So that means that PB equals 9. Okay, so now I have that KC equals 2x minus 6. I have that KZ equals 2x minus 1. So again, following the theorem, I know that K1, that KC equals 2/3 of KZ. So this part right here equals 2/3 of the whole segment. So in this case, I have 2x minus 6 equals 2/3 times 2x minus 1, right? Right here, I can multiply times 3 on both sides of the equation. So I can cancel out this right here. So now I have 6x minus 18 equals 4x minus 2. So minus 4x. So I have 2x minus 18 equals negative 2 plus 18. I have 2x equals 16, and now I'm going to divide by 2, so x equals 8. Okay, so in this case I have a RD, so it's this whole segment equals 3x, and P is this one small over here. Again, because it's the smaller part of that median, that means that this one is 1/3 the whole document. So 1/3 of RD equals PD, right? So 1/3 of 3x equals 2x minus 4. I can cancel this 3x right here, so I have x equals 2x minus 4. So minus 2x on both sides. So I have that negative x equals negative 4 and divided by negative 1. So x equals 4. But now it's asking me to find RP. So that means that first of all, I want to find the whole segment, right? So RP equals 3 times 4. That is 12. That's the big segment. So the whole segment is 12, right? So now, oh, this is RD, sorry, RD right here. So RP equals 2/3 of the whole segment, so it's 12. So in this case, is 8. And that's it for this lesson. May the force be with you.